Go.
Okay, that was awesome. It's really hard to follow up something like that. I mean, cloaking materials. I'll just have to go with what I got. Okay, a little change up. In this presentation, I'm going to be talking a little bit more about like classic web development stuff. Very recently, I did a blog for Perl Advent, which was on my Valiant validations library. Which was a blog about how I'm using my Valiant validations with DBX class. And I got a lot of great and useful feedback, including a number of emails. And I thank everybody who gave me feedback. But one thing that came up a few times was people were a little bit confused about the context, because in this blog, what I talked primarily about was actually at the DBX class level and how the validations were described and how it worked. What people didn't really understand was the overall context was like, how would you use this in something? So in this quick presentation, I'm just going to go quickly over a very small application that I wrote, a really classic like 2005 style CRUD application that is using Valiant and Catalyst. And I'm just going to show the code. So this is going to be like all code, not slides kind of thing. So just getting into it. First, I'm just going to show you the application really quickly. So this Agendum application, it's a demo application that I've written to like help explain how to use different new things that I've been doing with Catalyst. A lot of people learn from code, not from docs. So here's a code option for those code learners. So in Agendum is basically just a single user to-do application. And as in a lot of these to-do applications, you have your list, your list of everything that you're doing, working on. And then you have screens that describe details about each of those tasks. So in this case, this is a detail screen, or you can edit it and change different things about it. So there's labels, you can set priorities, due dates, you can add comments to it, pretty much the standard kind of thing that you might expect. And of course, it does validations, which is what the blog was about. And then of course, you can create new ones from scratch. So it's just a standard CRUD application. We've all seen 1,000 of them. So how does Valiant integrate with this and work with this at the Catalyst level? So let's first start by looking at the code and how code connects to particular screens. So in a standard CRUD application, you're doing updates or you're doing creation. So let's look at the update workflow first. So in this case, let me first show you the application. So I'm clicking on the edit for my number one task, which is walk the dogs. And it brings up a form via get. So let's go look quickly at what is happening behind the scenes at the Catalyst level. So in the Catalyst application, there's a controller called tasks, which chains off of the root controller. Now in Catalyst, actions can be chained, which means that an action you can set up your action so that one action follows another. Chaining or chain of command is a type of composition pattern that's used to delegate and decompose activities in the same way that you might decompose activities with roles and objects or with functional programming. So Catalyst encapsulates this model. So in this case, when you go to hit this screen here, the update screen, it's first going to go through the root controller, and eventually it's going to bubble up to this tasks controller. Okay, and it's going to hit this action, the root action. And this root action is going to go and get the DBX class result set for the looking at the task, which includes the task information, like the name and so forth, and its sub information, the comments and the labels, which are actually represented by different tables. Okay. And again, just remember with DBX class, when you create a result set, that's actually not hitting the database yet. It's creating an object which represents what the database query would look like if you asked for it. So DBX class is very efficient. It doesn't actually run any SQL until you specifically ask for it. So it's going to go get that result set, and then it's going to pass it on to who's ever next. Now, again, in chaining, you can have multiple actions might chain to a given parent. So if you're on the task controller, which is represented by that list, you might then just simply pass on that result set to the form or to the page that's going to show you what that list looks like. But in this case, we're actually going to go on to the next controller, which is named task, because that's representing that's representing everything to do with a single task. So at first, it's going to hit the root action. It's going to pick up the task's result set. Not a lot happens in the root action. A lot of times in Catalyst, you'll see this. You'll have a lot of actions that don't do a lot, particularly at the beginning. And it's still a good idea to decompose your actions, because what I find is as time goes on, you need to have good places to put code. And one of the great things about breaking up your actions into small discrete parts is that you get really useful places to put stuff, as opposed to having just one big long like massive function that takes everything. So it's going to get that result set and it's going to then pass it on. So how do we represent this page here? So this is a get that's showing this form. So again, going over to the code, it's going to then go down to the find action, because as you can see here, just going back to the application, it's going to tasks. I don't know, maybe you can't see this, it might be hard. It's going to tasks and it's looking for task ID number 2. Okay.
We can see it.
Okay. And then it's going to jump over to this find. So it's going to take the result set. It's going to find it by task ID. If it doesn't find it, you get a 404. Otherwise, it finds the task and it passes it on to the next, to who's ever listening to it. Now, there are 3 actions that listen to find: show, delete, and then there's this update sequence, which we'll get to later. We're going to look at show. So show is just simply going to take the task, it's going to pass it on to the view. Just go look at that real quick. So this is the form view. So that task is coming in. Now, again, a lot of Catalyst applications, you're probably used to passing information to a template via sticking things in the stash. In my application, I prefer, and I've been promoting this concept of having strongly typed views. That is a view that defines in its attributes what it needs in order to function. So in this case, this view is saying, I need to have a task. Otherwise, I won't even compile. So it's going to pick up that task, and we'll just skip down to the actual template itself. So it's picking it up here. There's a helper called form that gets the task, and underneath it, it then goes and it builds the HTML for all this. This form builder is built into Valiant as well. So Valiant has validations as well as form building. So think of it as similar to, like, say, a Ruby on Rails, where it builds both everything into it into one. And then it's just going to go through and it's going to build each of these pieces. So just looking at one really quickly, the title, it's creating the label, the input field, and any errors get displayed. And of course, you can pass things like CSS classes and so forth. Documentation role, this is part of Valiant, and I'll paste those links into the chat when I'm all done. So, and that's it really in terms of the get. That's all that's happening for get. So what happens when you actually, and this gets into the heart of it, what happens when you get into actually like doing an update? So let me just create some form validation issues. I'll remove the description and I'll try to set the due date to the past. So I'm going to click on update. So it's now Valiant is running in the background. It gets that DBase class result set. It's looking at the definitions, at the Valiant validation definitions, and it's finding issues. And it's just, and then that will then bubble back to the form so that you can see what's going on here. And let's just quickly look at the code for that, because the workflow for that is a little different. So again, we're going to come into the task controller. It's going to go to the root action. It's going to pass on the tasks. That goes down to the find action, where it finds the task you're talking about. And then it's not going to pass it on to show, it's going to pass it on to this update group. So again, I like to break up my actions as much as possible. There's no reason why you couldn't make this one action and say, if it's a post, do this, if it's a get, do something else. I prefer it this way. If you prefer fewer, you could do it that way as well. In any case, it's going to pick up the task, okay? It's going to set up the view by passing it along. And then depending on whether or not somebody's doing a get or they're doing an update, in this case, we're doing an update, it's going to go to the update action. That update action is going to take the request. It's going to pass it on to a model that is modeling what that request is expected to look like. So in other words, instead of just getting like a hash of parameters back, we're actually getting an object back that represents the request. This is another pattern that I've seen in other systems that I liked, because one of the things that I find is you have to be really careful with incoming parameters. You can easily open up security holes if you don't clean your incoming parameters properly. And I also find that you're in applications, particularly as they get older and more complicated, you do get scenarios where you need to do a lot of munging around the the incoming parameters, and so it's nice to have a place for that. So that object comes in, and then it gets passed down to a common shared method called process request. So just going back to here. So now task, remember, that's the DBX class result, okay, that you've instantiated. I'm going to take that model and I'm going to use that model to update the task. Now, when I say update the task, what I mean is it's going to the DBX class and it's updating the fields, and it's doing it so recursively. So it's updating the fields on the task model, and it's updating fields on either the comments or the labels, which are child fields underneath task. Okay, and it does that neatly and recursively. And there's a few other interesting things, like you can mark fields as deleted, or you can mark things as like if you're adding a new comment, you can mark it as this is a new incoming comment. And then in this case, if it's a new comment, I'm just validating it and I'm passing it on. You don't want to, if you're just adding a new comment, I don't want to update the whole thing. Otherwise, I'm calling insert or update, which then runs the validations. It updates the view to let the view know that to give them the user a message that the document was saved. And then that goes back. So then again, that goes back to the same form. And this is what's like great about using the DBS class result sets and results in a consistent way. You can use the same incoming interface for both the get side of the form and the update side of the form. Now, it'll come in, again, it'll go to the task attribute, and that'll get the template will run. And the template just takes that model and then it creates HTML fields. And the scenarios where we have errors, when you hit when you're checking for errors on the form builder, it'll notice that there was an error. Like we said, okay, there's an error here in the description field, and it just knows that there's errors that were associated with that Valiant, with those Valiant constraints, and it just displays it. On the create side, it's also very similar. We'll just go back. It's not always the case that your create and update forms are identical. In this scenario, it is, but there's no reason why they wouldn't be different. They're actually usually they are different. Usually quite often creating something, you'll have additional information required. And in updating, there'll be things you're not allowed to change. In this scenario, because again, I'm trying to keep it simple for learning purposes, the create and the update are identical. So it looks identical to the user here. It's just again, when it hits the Catalyst side, it's following a slightly different workflow. And we'll just quickly glance at that. So again, we're going to come through the root controller. We're going to come through the task controller, and we're going to bubble up to the task controller. The task controller will receive the list of tasks. And in this scenario now, since I'm following the create workflow, okay. So instead of getting that ID, we know we need to build a new one. So it's going to ask for a new task. The new task sets up some basic field stuff, like it sets it by default sets the task due date to tomorrow. You can change that, but it's just a way you just set some defaults. So that gets set up, and then it passes on that new tasks to whichever action is listening next. In this case, I'm going to go down to the setup create task. That's the next one, which is listening to the build action. It's going to then create the view and pass on the task. Again, this is a strongly typed view. The view expects certain types of information in order to be able to instantiate it all. So it creates the view, and then it's going to pass on to the next listener, which is going to do, it's either going to be you're getting it because you're viewing it the first time, or somebody you've actually clicked on create and you need to process it. And the create is very similar to the update. Again, I'm getting a getting those incoming requests. The incoming request is passed on to a model. That model instantiates itself from the incoming request, and it'll fail if the incoming request is like a hack attempt or it's incorrect. It then takes that model, as opposed to like a hash ref, and passes it on to the process request subroutine, which is the same one as with update. And again, it's going to follow the very similar process. It takes the tasks, it updates, or it sets the field based on that incoming model. Again, it sets it, but it doesn't actually tell the database to put anything into the database. Okay, that's handled in a separate step. When you do the insert or update, the validations run. If the validations pass, the creation goes ahead and happens. If it doesn't pass, then the insert doesn't happen, but the DBAS class result is maintained with the fields that have been updated by the incoming parameters. And in addition, you get the errors attached. So that then when you go back to the form, which I believe is here, again, it follows the same process. It'll go through. We'll create a form for that task. This form builder object knows all about its underlying model, and it'll create HTML forms based on your requests. And in the scenarios where you have errors, such as errors on the description or errors on the due dates, those get populated automatically. So like this, for example, this errors for. This errors for will automatically return an empty string if there's no errors. So that was just to give you a little bit of context for anybody who read this and wanted to get a better sense of like, well, how is it used in a greater sense? That's how it's used in a greater sense. And I'll just put in, where's the chat? Equal messages. Okay, I'm just going to put into here the links for everything. That includes the Advent article, the GitHub for Agendum, and the Valiant on MetaCPAN. If anybody has any questions, feel free to ask me. I'm JNAP on IRC, or you can email me. My email address is attached to the blog. And thank you very much.